As I've mentioned, we'll deal with the application structure now. It's slightly different than in the case of Eclipse. If you've already used Eclipse, you'll definitely notice small but significant differences. The entire project generated by us is included in the Hello Android directory, which is saved in the place we provided when creating it. The project itself includes the so-called module. In our case, the Hello Android project includes one module named App. In the case of Gradle, we can have multiple modules which can be interdependent. Modules available inside the project are described in the settings.gradle file. In our case, we have an information here that Gradle has to import a module named App, which is to be found in the current project directory, which we know thanks to the colon punctuation mark. Additionally, we have the build.gradle file, which is the main file used to define the entire project. In our case, this file is very simple. It's actually the default version of build.gradle. This file only informs us that we use the 0.12.2 version of the Android plugin for Gradle and add some additional repositories. Each module has its own build.grade file in order to define the behavior of a specific module. In our case, the app module uses the com.android.application plugin. It informs us that this is an Android module. While Gradle may be used in various projects, using this particular plugin means that everything here will be strictly Android related. The entire configuration is present in this file, which informs us what should be present in the module. Here we have a couple of things we should pay particular attention to. We can find the SDK version, which will be used for the compilation. In our case, it's the latest possible version. We also see here the Build Tools version. It's the version of the tools available in SDK. The purpose of the tools we use is building applications. From time to time, they are updated by Google to add some new elements. Due to this, the currently used version is provided. Further, there is a default configuration which specifies the main elements important for the given application. In our case, the application ID is a very important element. It's simply a package. It defines the package generated by us, which specifies that our application has to be available under the given package. Another thing is the min SDK version. It's the element we previously defined as the supported API version. Target SDK version specifies the latest version we want to support. The target version defines for us which latest features we want to have in our applications. If we set version 20 here, we'll be able to use all the elements available in version 20. We could limit it to version 19, but then the elements later than this version would not be available. and any attempt to use them would end up with an error. Yet another thing is the version and the version code of our application. The version code is the most important thing. It's an integer number which specifies the subsequent version of the application. Based on this, the system is able to determine whether the version we're trying to install is later than the one we currently have. Version name is a described version where you can enter any expression. Usually, the version_main.version_smaller.version format is used. It's not interpreted by the system and used solely to display the currently installed version to the user. Another section is build types. It specifies the configuration for particular types of packages created by us. When creating a release version package, we have a certain configuration. When creating a debug version package, we can create a separate configuration. In the case of Gradle, it's important to remember that it works on the basis of the principle convention over configuration. This means that the behavior of certain elements is already configured. If we want to, we can overwrite any element in a specific place, thereby modifying the default behavior. In our case, we have two things related to ProGuard, which I've already mentioned, namely reducing the size and scrambling the resulting packages. At this moment, it's good to notice that we have run ProGuard set to false. This means that in the release version, ProGuard won't be started for the time being. If we change the value to true, ProGuard will be run when building the release package. The ProGuard method of operation will be described by the files present in the line below in ProGuard files. At the end, we have the dependencies section, which is most often modified in case of applications. It specifies which files will be attached to our project in order to build the application. In our case, we have one default implementation. It informs us that everything which is present in the libs directory of the module and has the name .jar has to be imported to the project as a dependency. If we put some .jar files to this generated libs directory, they'll be taken into account in our project. It's done automatically in Eclipse. This is also the case here because the line mentioned above is generated automatically. If we would delete it, this mechanism would simply stop working. I changed the file a moment ago, so Android Studio noticed the change and informed me that Gradle files changed as well, and that they must be synchronized with the Gradle file. Due to this, the sync now function has to be called, which will cause the entire project to be rebuilt with a simultaneous synchronization of everything from Android Studio with the Gradle files.